Hello and welcome to the session on thrust bearings. As we have discussed in the earlier session on thrust bearings, we have learned the different types of thrust bearings. In this case, we will learn a problem on collar bearings. So problem statement goes like this. The thrust of a propeller shaft in a marine engine is taken up by a number of collars integral with the shaft, which is 300 mm in diameter. The thrust on the shaft is 200 kN and the speed is 75 rpm, taking Fc constant and equal to 0.05 and assuming bearing pressure as uniform and equal to 0.3 Newton per millimeter square. So you need to find the number of collars required, power lost in friction, and heat generated at the bearing in kilojoule per minute. So one thing you need to understand in this problem, it is a marine shaft used for the propeller where the collars are integrated with the shaft. We need to calculate how many number of collars are required for this purpose, and we need to calculate what is the power lost in friction and also heat generated in the bearing in kilojoule per minute. As you can see, we have done problems on journal bearings where power lost in friction is also equal to heat generated in the bearing. So both can be taken as same in this case also. As you know that heat generated depends upon the friction which is there in between the mating components. So thereby you can see that both are one and the same. So for this case I am using K. Madhivan and Balivir Reddy as a data handbook for my reference, which is of 4th edition. And first we can write down the data for this problem. So one is diameter. He has given diameter of the shaft is 300 mm or the radius can be taken as 150 mm. And for this condition, load which is acting axially to the shaft is 200 kilonewton, that is 200 into 10 power 3 or 2 lakh Newton. So the speed he has given in terms of rpm, that is 75 rpm, and the coefficient of friction, that is of the collar experienced by the collar, we call it as a collar friction, that is 0.05, and the pressure developed in the bearing is 0.3 MPa. Next, first thing is we need to calculate how many number of collars are there in the bearings. So for calculating the number of collars required, so we need to take that, let n is the number of collars required that we need to calculate, and since the outer diameter of the collar is taken as 1.4 to 1.8 times the diameter, as we have learnt in case of design aspects in earlier sessions, we know that outer diameter of the collar, that is whatever d outer diameter, which is nothing but the collar outer diameter, can be taken as 1.4 to 1.8 times the diameter of the shaft. We know that. For that reason we will consider this capital D as 1.4 times diameter. So if I take 1.4 times the diameter, which will be 1.4 into 300, where you will get the value as 420 mm, or radius as 210 mm. So that means we have got the value of diameter of the collar, that is outer diameter of the collar, and the radius of the collar, which is 210 mm, which I have shown in the figure. You can able to see here from the axis of the shaft to the top surface on the collar. And next thing, we know the formula for pressure. It is nothing but load by area. And area in the sense here, since he has asked to calculate number of collars, so number of collars has similar areas here. For that reason I have multiplied the area, which is pi into the capital D minus small d, or you can take, he has measured in terms of radius, what I will take as pi into r square, which is the radius of the collar, minus radius square of this radius of the shaft, where you can get the area of the one collar. So if you have number of collars, you can multiply with n, so that you can get the value of number of collars. So in this case I will substitute, since P is given 0.3, where, and also you know the value of R, which is 210 mm, and you know the value of radius of the shaft, which is 150 mm. So if you substitute both all the values in this case, you will get 2.947 by n, and cross multiplication you can get the n value as 9.8, or you can say it as 10 collars which have been used in this propeller shaft. So if I go to the next calculation to make, next thing we need to calculate the power lost in friction. So in this case we have a equation in data handbook where we can able to calculate, first we need to calculate the torque, then we can able to calculate the power lost in friction. We have an equation for power loss, 2 pi nt by 60, where you will get in terms of watts. So for calculating this, first we need to get the what is the torque. So torque is nothing but torque generated at the collar due to the collar friction. So we can have that equation 9.11 g, page number 134, where you can get the equation for torque on the collar, which is Fc into W into dc by 2, where Fc represents the coefficient of friction of the collar, where W is the load which is acting axial into the direction of the shaft, axial to the direction of the shaft, and dc represents diameter of the collar. That means since two diameters we have calculated, we can use the formula for dc, that is diameter of the collar, as mean. This dc represents the mean diameter of the collar. Please understand that mean diameter we need to calculate. So since I am considering truncated collar, the equation will be dc is equal to 2 by 3 d dash cube minus d double dash cube divided by d dash square minus d double dash square. So this also is there in the data handbook, near to this same equation. It is having that. So since I am considering truncated collar, this will be the equation, and d dash represents the outer diameter of the collar, that is 420 mm, and d double dash represents the inner diameter of the collar, that is 300 mm, and similarly dc, if I substitute d1 and d dash and d double dash, you will get dc as 363.33 mm, where in this case tc after substitution you will get it as 1817 Newton millimeter, so in terms of SI units. So then we need to substitute this torque in this equation, where you will be getting the equation you will be getting the value of power loss in friction as 14.27 kilowatts. And last thing, as I told you in the previous case, in the design of journal bearings also, so heat generated at the bearing is almost equal to the power loss in friction. So same thing we will be applying in the collar bearings also. Whatever the friction experienced by the collar will generate the heat, the same can be taken as the value of power lost in friction. For that reason, you can say that power lost in friction will be equal to 14.27 kilowatt, which we got in earlier case. That will be taken as the value of heat generated. As he has given to calculate in kilojoule per minute, you need to multiply whatever the value you got into 60, so that you will be getting in terms of kilojoule per minute. As you can see here, it is in kilowatt, so I need to get it in kilojoule per minute. So for that reason, so since watt is equal to joule per second, where this will be kilojoule per second, so kilojoule per second to minute is nothing but 14.27 into 60, where you will get the answer as 856.2 kilojoule per minute. So here heat generated at the bearing and the power lost in friction will be equal. So hence this problem is solved. I hope you have understood the problem. Thank you for watching. Have a good day.